Matter versus antimatter, the ultimate cosmic showdown. Imagine for a moment the universe as a colossal arena with two equally matched opponents. Matter, the stuff that makes up you, me, the stars, and everything we know, and antimatter, its mysterious twin, identical in mass but opposite in charge. For decades, scientists have been obsessed with this rivalry, because it's not just a battle of particles, it's the story of why anything exists at all. And guess what? We finally have a tantalizing clue about why matter came out on top. Let's rewind the cosmic clock to the very beginning. Right after the Big Bang, the universe was pure chaos. There were no galaxies, no planets, not even atoms, just a wild, seething soup of unimaginable energy. In this primordial cauldron, energy was constantly transforming into particles and antiparticles, popping into existence in perfectly matched pairs. For every electron, there was a positron. For every proton, an antiproton. The universe was a perfect balance of matter and antimatter locked in a cosmic dance. Here's the catch. When matter and antimatter meet, they annihilate each other in a flash of pure energy. Poof! Gone! It's one of the most dramatic events in physics, and it means that, by all logic, everything should have canceled out. The universe should have ended up as nothing but a cold, empty void, filled with leftover light. But that's not what happened. Somehow, matter survived. That's why you exist. I exist. And yes, even pineapple pizza exists. Every atom in your body, every star in the sky, every planet, tree, and slice of pizza is here because, against all odds, matter gained the tiniest edge over antimatter. But how? What tipped the scales in favor of matter, allowing the universe as we know it to form? For decades, scientists have scratched their heads, running experiment after experiment searching for the tiniest clues. They've built massive particle accelerators, pored over mountains of data, and even looked to the farthest reaches of space for answers. The question of why matter won is one of the deepest mysteries in all of science, a puzzle that has stumped even the greatest minds. Enter the Muon G2 experiment at Fermilab, a cutting-edge project that's been making headlines around the world. Nestled in the heart of Illinois, Fermilab is home to some of the most advanced particle physics experiments on the planet. The Muon G2 experiment is designed to probe the very fabric of reality, searching for subtle clues that could explain the matter-antimatter imbalance. The star of the show? The muon. Think of muons as electrons' heavier, moodier cousins. They're unstable, short-lived, and incredibly tricky to study, but they hold secrets that could unlock the mysteries of the universe. By observing how muons behave in powerful magnetic fields, scientists can test the limits of our current understanding of physics. And get this, muons wobble in magnetic fields in a way that we just can't explain with our current physics. This tiny, almost imperceptible wobble is like a fingerprint from the dawn of time, hinting at forces and particles that lie beyond the standard model, the framework that describes everything we know about the subatomic world. The Muon G2 experiment has measured this wobble with unprecedented precision, and the results are, well, let's just say they're raising a lot of eyebrows. That tiny wobble could mean there are mysterious new forces we've never seen before. Forces that might have tipped the balance in favor of matter at the very beginning of the universe. Imagine hidden particles, unknown interactions, or even entire realms of physics waiting to be discovered. If these results hold up, they could point to a whole new layer of reality, one that explains why matter survived and antimatter vanished. If this holds up, it could totally rewrite our understanding of the universe. We might be on the verge of a scientific revolution, one that changes the textbooks and reshapes our view of reality itself. The implications are staggering: new physics, new particles, and maybe even answers to questions we haven't thought to ask yet. So, are we on the verge of the biggest breakthrough in physics ever? Or about to uncover something even weirder? The search is far from over. Every new experiment, every new measurement brings us closer to the truth. The universe is full of secrets and we're just beginning to scratch the surface. Who knows what we'll find next? Maybe the answer to why we exist is stranger than we ever imagined. Hit subscribe for more cosmic mysteries, because science just got a whole lot more exciting. Stay curious, keep asking questions, and join us as we explore the frontiers of knowledge. The universe is waiting, and the next big discovery could be just around the corner.